I want to thank first Sunit and the Brainiac team for having me here, or firstly for the wonderful event, and then secondly having me here for the said topic to express my thoughts on. And so what I'm going to do is I'm going to share about my experience with Forbes Marshall from last 20 years in the research and development, and especially about the last 4 years when I'm doing the innovation management for them, and we'll try to put up into the context what we are discussing. Also, thanks to Mahesh, who mentioned that that the advantage, or rather than advantage, the disadvantage of having the last into the room is that everything is covered. But there is also an advantage to that. Whenever you are uncomfortable on the points, you can say that I agree with the previous presenter who has already expressed their views into the same thing. So that is the advantage I am going to take, the liberation part of it. So before starting, just a very quick introduction about Forbes Marshall. As again Mahesh said, it's a very legacy-driven organization, around 80 years of existence. It's Pune-based multinational company, started in 1946. Around 30 offices globally, around 30 offices in India, the regional offices, very vast range of products, around 300 products. 5-6 manufacturing facilities, 4 of them actually in Pune, one of them is at UK, Bakewell, one of them is at Singapore. And very trained manpower in terms of research and development, around 100 members. So total members is around 2,400. It's more from the perspective that it's legacy, but the product range typically consisted of very less known products in a way. So we are into the steam generation, steam distribution, steam utilization, and condensate recovery aspect, and every single product we manufacture into that. Probably the closest known product will be boilers, where we have solid fuel, liquid fuel, gas fuel, all fuel boilers is what we manufacture. That's probably the known product, but there are multiple of around 200 products that I am listing into the steam line which is required. But apart from that, there are various sensors, process industry equipments, etc., that we manufacture for the wastewater quality, for the emission measurement of NOx, SOx, CO, CO2, etc. So whole lot of instrumentation, whole lot of process equipment required from that perspective. So everything about the utility for the process industries is what we do. And these are the industries we serve with. So it's food and beverage, pharma and chemical, textile, tire, rubber, chemical, sugar. So we call it as like pasta to power and sugar to steam. Everyone we serve, and everything has steam because of its sterile nature, because of its relatively less cost available for the drying process, for the evaporation, and that's why everywhere is steam. But it's kind of a very invisible, and that's why the products are very less known. So that's what we do. So let's get back to the topic. And I want to start with what are the expectations from innovation when we say that we have an innovation team. When we talk about an R&D, what are the expectations from the R&D team? So if you look at, there are something which are input to innovation, then you expect something as an output part of it, and then there is a process in between which you practically try to manage in R&D. So what is the input to that? Input is about what is your strategy. Input is about what are the customer needs, and I'm going to elaborate much more on customer needs going forward. The infrastructure you give to the R&D team, and then the budget part of it, that whatever the budget allocation for the infrastructure, budget allocation for the testing, for the software, everything that. So all of these are input. And in terms of that, when you give that an input, what you need or what we expect from the team as an output is about industry leadership on the chosen product. You want the new product revenue to go up. You want timely launch of the product into the market, which in turn will help you in sustaining the product leadership. The gross value adds. So you expect the profit margins to be much higher when you are doing the R&D. And then you need the IP portfolio. So all of them are basically talking the same language of industry leadership, whether it in terms of revenue, whether in terms of knowledge, whether in terms of technology, but that's what your expectations are. And what you do into the processing part, you try to manage the process with the help of people, process, and the culture that you set up. And through that, what you try to do is the technical excellence, the teamwork, the risk management, the product management portfolio, the passion and the development process and the framework and etc., all of that. But ultimately, by doing this, what you are basically doing in R&D is you are managing people, you are managing processes, and in turn you are trying to manage the culture of innovation. That's what, at a very nutshell, which you are doing at an R&D level. So, what is changing? Why we are discussing this topic itself at all? So, if you remember, this, I can talk about 20 years only of my career. Is that previously there was a need that when you have to develop a product, there will be a mechanical product, there will be an instrumentation product or electronics products. There are separate teams for that. They will develop the product, and the expectations were very simple, that it should perform. And it should perform to the specification, and that was it. That's what the bare minimum expectation. Today the expectations are very different. Mechanical, you need electronics, all of that, it has to be combined, the embedded system has to be there. Not only that, you expect the product to perform well. If it is not performing well, you should know that. Not only you should know that why it is not performing well, but you should have all the corrective measures and the go-to actions defined for that. And now our expectation is that it should correct itself. So that not only product as the product itself, but it should do everything. Along with that, you want all that data to talk with each other. So the 3-4 equipments, 3-4 processes inside the customer premises should talk to each other, and then they will give us a gross efficiency at a plant level. So now if we are changing from the expectation and the market is changing, the way we innovate also has to change. So what is changing, or where is the change that we are seeing, that where it is happening? So if you look more from the perspective of what used to happen, is that when we used to say that an innovation and how we are doing it was more centric towards the conventional and SME based previously. So we were very close, we wanted to keep everything to ourselves, our R&D expert, our subject matter expert will do that was the mode. Today you are not left with the choice. You have to go externally because you can't do everything in-house. So you have to go to the startups, you have to go to the incubators, you have to go to the individual innovators, you have to go with all the facilities or all the ecosystems that you know. Of course, the academic part which we have been talked about, I will just briefly touch upon that. But I think there is no option for all of us now. If we are saying the way we are innovating in itself is going to change, it is already changing, and that's why we are seeing a huge surge into the number of startups being coming up, although relatively lesser, but still into the core tech or deep tech area that we call upon. The second point was the tech as a support. So we had CFD, we had CAE, those were more from the fundamentally from the point of view that we will design and then we'll just validate it. Or we have the ERP systems which are kind of a process into the R&D or process into the organization. So they were supporting role previously. Now it's no more in that case. They are basically the pillar of your R&D. They are driving it out. The digital twins are helping you to do it much faster getting into the market. The various data analytics tool for UI, UX experience mapping is helping you to decide your strategy of new product launch or what the next product pipeline you should be having. In the morning, it's already mentioned regarding the car, what we talked about, but it's also applicable to all the industrial product also. The third point is IP as a protection. So we used to file IP for protecting ourselves. Now it's no more the case. IP is the new currency in that term. And just a very small example for that, we are a 2,000 crore company. But if we today go to a startup who has a brilliant idea and we want to collaborate with them, and they do not have any commercial installation anywhere, the concepts are at paper level, they are at TRL 3, TRL 4, but just look at their valuation, what they credit. So based on what they are kind of giving you that valuation, that's just the IP, the differentiation, the great customer need they have identified by themselves. So IP is the next currency on that part. So there is a shift in which we are looking at the IP also. And then the last part is also about the customer need or companies what they are going to develop. So as I know, or rather than I know, I heard about that there previously used to be the waiting time for the cars to come up. Now it is just impossible for us to imagine that there is a waiting time for the cars. And that is because the customer is driving the innovation now. So you have to have a very clear-cut strategy in identifying the customer need and based on that you have to develop your products. So there is a drastic shift in which the market is changing, and there is a drastic shift in which you have to innovate yourself now to tune into that. I'm going to touch upon the first one and the customer experience mapping and the need finding methodology that we follow briefly. But looking at the paucity of the time, you know what I will do? I will just stop maybe a couple of slides on the time versus quality. So basically, it's reliability versus early launch, the customized frameworks that how you should differentiate the product and what should be their percentage numbers, and then the innovation culture. The probably innovation culture is the most important part. And Mahesh was also talking about the same thing, that how he's trying to get into an early wins and trying to get into that mode of having that innovation culture itself. So that's one of the point I would like to touch upon. So getting into the first part, this is a well-known picture that this is how customer explained, this is how the programmer understood, this is how he explained to the developer, etc., etc. So this is well known. But I want you to focus on first and last. It is talking about how customer explained it, and the last one is talking about what he wanted. So firstly, let me clarify wanted and need, I will come to that. But wanted and explained, what does that say? That even many a times customer will also not be able to explain what exactly they wanted. That's the first point. Secondly, customer will always have wants, but what you should give it to them what they need, because need is more explicit. Need is what is basically going to serve them. So one of the framework is something like this. So firstly, look it into more from the perspective of Q1, where we are talking about there are customer needs and you have identified their needs. In that case, whatever you will deliver will basically the customer expectations will be met by your products. So it's a win-win situation. Secondly, the second quadrant, basically Q3, is about customer don't know, you don't know. So fine enough, there is no problem into that, no harm zone. Now let's come to the Q2 part of it, where customer doesn't know, but you have identified it correctly. So there is a good possibility that customer will be delighted and you will get the premium what you are kind of envisioning to go along. But the last quadrant, which is Q4, that customer knows and you are not identified, and still you are going ahead and developing the product and then trying to enforce it on him. That's the disaster. And that's where the point is that you need a very robust, very sound mechanism in order to understand what exactly the customer needs are. So very small and very quick example. So we are into a boiler manufacturing business. And we decided that using the data analytics part of it, data analytics and sensors and everything put together, we want to develop an unmanned boiler. So the boiler should not require an operator. So from that perspective, we started the need finding, and basically rather than need finding, we decided to embark our journey on the product development. Of course, very quick amount of time, we realized that there is an IBR regulation. IBR is Indian Boiler Regulation. We say that the operator has to be there. So we cannot make it unmanned, and even if we can make it unmanned, the operator still has to sit there. So we change our trajectory and say that we will augment the boiler operator. So how we should do that? So what we did is basically, we chosen around 8-10 number of sample sites, and we decided that we will follow exactly what the operator do. And that's what we did, that the shadowing effect that we call it, that we just followed the operator. So he used to come, he used to take a photograph of many things, and then he has a register, the logbook they call it as. At every hour, he has to fill the data into the logbook. That what is the steam flow, what is the fuel flow, what is the electricity, what is the air, etc., whole of that of data. But for collecting that data, he has to go to many places, as you can see it here. So he has to go everywhere, take a photograph, come back, rewrite it into logbook, because logbook is very big. You cannot carry logbook everywhere. Then he has to go outside and see the boiler, the chimney, what is the color of the stack. So if that color is black, then he has to do something. If color is white, still he has to do something. It has to be transparent, etc., many things. So this is what we map. But along with that, what the process will follow is that we make a cross-functional team. We go there, we study this, but we allocate the roles to the people. And what do they do? One person go and he only observes the thing. He will not speak any word. The second person go and only ask questions. which are related to technology, and he will keep on engaging with the operator. The third person will go and ask very open-ended question that if you are given 1 lakh rupee, 1 crore rupee, what will you do? When in the last time you got a call and you got into stress, etc., such type of questions. And the fourth person will just observe that what is happening in and around. So while doing so, this is what also we mapped. This is also about what is the condition of the place where the boiler operator is working. Is there any kind of a noise? What is the physical activity he is doing? What is the sensory things he is doing? How is social interaction? Because boilers are normally kept at very far away from the plant, and that's where the boiler operators are normally in isolation to an extent, and their only social activity happens when there is a tea break, when there is a lunch break, etc. So this is what we try to map everything, that there is a lot of noise, why there is a noise, etc. But along with that, we also map that how is their emotional behavior. So when he's coming into the morning, normally when you start the shift, you are into relatively fresh mood. But they were more happy when the shift is ending. Naturally, of course, they are going home. But along with that, what we map is that whenever there is a logbook filling is to happen, there is a certain amount of drop, and you can see that the dotted lines which are representing is their emotional behavior when they have to fill the logbook. So that is stressing them apart. So what we did was, as a very basic first step, is that we have given a system that all the readings he has to put into a logbook, we just gather and given him at one place, which is very close to the logbook, that now you only see to this and write it to this. That has actually given us the acceptance. So what we understood from this is, of course, that we can make a good product, we can make leverage IP, we can do a unique and differentiation product, etc. But ultimately, success of it will be delivered and defined by the operator who is going to use it. So that's just the one point I want to give it more from the perspective that how we approached it. Secondly, there is always a discussion typically in R&D that when should we launch, are we ready, is the enough testing is done, how reliable are we, whether we should be doing it, etc. And of course, none of us design for failures. But what we say is that fail early, but it should be safe, because I'm talking safe in all the context, because in our case it's boiler, so it can be harmful even for the lives of the operator. But apart from that, it should not be too costly, it should be fast. But apart from that, it should be data rich. It should give you something that you can kind of improve upon. Otherwise, there are too many variables which you are taking a risk on, and then you don't know that it is failed, but why it is failed and what should I improve, then there is always a problem. So have that risk very clearly defined, and the failures you need to understand, kind of, and document it and move along. But along with that, how it is changing now is again the use of digitally connected R&D, where you have the digital aspect which you can use to fail fast, validate fast, and that you should do very quickly, because then you can try multiple iteration, multiple simulation, and not only I am talking about CAE, CFD, but also your S3s which you have in your own premises. They can be digitally connected. You can map the data for 24/7 and do quickly that part, so that then you can build and release the thing or the multiple versions of thing in physical nature. So using the digital technology to your advantage is also one of the points that we should be very mindful of. Third thing is having the customized framework, and there are many frameworks as I have listed here. So for the people from the academic background, the speed gate process is the very common terminology or common framework gets followed, where you have S for study phase, P for prototype, E1 is the internal testing, E2 is the external testing, D is the delivery to the cross function, that sales team that now this product is ready, or for the manufacturing that you should start the manufacturing of it. That the speed process you should follow. While doing this, what we realize are two things, is that once the product is delivered, the R&D rule actually ends, but still the product may not do well into the market. Then what we can do? So that's why we added the post-D feature into that, where we are saying that the performance tracking of the product, and if it is not doing well, that also need to be well understood by the developer himself. He has to understand that what were the assumptions, what were the approximations made during the development of the process, and what have changed now. There could be a competitor who has done something that you have to still integrate, or the need has vanished from the market. So he will be the best person to understand to start with. And then there is the pre-A page which we added, as I just mentioned about the customer need finding, and that rigorously we need to have a framework only for pre-As, and that need to be very well followed. The point which I am trying to make is that you need to customize the framework. There will be standard framework always available, but you need to tune it to your requirement, because for software they could be different, for the automobile it could be different, for the industrial product like us it could be very different. Now you have this for products, but now you have also external collaboration which you are going with. So you have startups, you have academia, you have individual innovators. What will you do with them? So we decided to have another framework into the similar line as I mentioned about the Aspire. You can use any, but have the framework so that you can track. As Mahesh mentioned that the numbers, when you put it into numbers, then everyone gets interested into it. When you are showing it into the dashboard, people understand that you are progressing, not progressing, where are you? So that's why frameworks are very important. And then the horizons, again, this is very common terminology and you can put it into it, is that first protect your existing market. The sustenance and leadership into whatever you are doing is always H1, where you put maximum amount of percentage of people in R&D. So we have that stationed around 30%. So whatever product we develop now, we will be counting it as a new product for the next 5 years if the product is patented, or 3 years if the product is not patented, and then we count the numbers and the total sale, and the target is around 30. So we never touch 30, but still the target stays as 30. We will be around 18, 20, 21, 17. That will keep on hovering, but the target is still 30. And as I said, is that external kind of an ecosystem and digital is a must. So that data is not only for looking at the dashboards, not only looking for what's happening, but it's basically to use as a product defining strategy. So it's basically product management, what you are going to do. It's the use of it. Somehow you have to figure out how you will use that data, reach what you are getting along from the cloud and everywhere, whatever the infrastructure you are having, in defining your future product pipeline. So that's how the overall aspect that those should be covered in a way. So what could be the very smallest step to start with? So it could be next 7 days if you remove one of the process into the manufacturing, or if you do one experiment which we haven't thought of at this point of a time, that the innovation journey will begin. So that's what, those were my thought. I just wanted to put it, and I just wanted to complete before time so that you will get more time on that perspective. Thank you all.